to give up some small insight about our concrete use cases, we have chosen 2 use cases, and one of the first one, which will be presented by Sebastian, is more or less the first use cases that we applied with Hadoop for about 2 years. It is quite simple, but I think a good example of how data can be traded in Hadoop. And the second one will be about recommendation from the data. So, Sebastian.
Where is it? On which side? There it is. Great.
Einfach Windows P, dann hast du.
Ach, stimmt. Again, welcome. I'm Sebastian Muller. I'm a software developer at Autoscout, and yeah, as Jizzy always told, I want to present you the dealer statistics. Maybe you sold already a car on our platform, and you know it's free. But if you have more than 2 cars at the same time, you need a premium account, a dealer account. But with the premium account, you also get premium features. And one of those features, make it full screen, is our statistics. So you can analyze how many people have seen your car or vehicle, in how many searches your cars were present, and how many people have it on bookmarks, and how many emails and phone calls you got for it. It's aggregated for each classified, for each vehicle, and another aggregation step for each customer. So, what do you think how we do it? Normally you would analyze the log files of our IIS servers, but we have problem with, we have a lot of crawlers, grabbers, which always scan our website and use it to index the data and want to have it on their database. So if we would use the IIS logs, we would have a lot of those grabber data, and that's nothing we wanted. So on every page view of a vehicle, we send another request again back to our servers. So this is made with JavaScript. So the grabbers, which only analyze the HTML, don't execute our JavaScript, and there we can decide which is a real user and which one is a machine, a grabber. Those data consists of this query string at the end. I will show you later what's in there. But all these query strings are written again in the log file. The log file is streamed with Flume. Christian already presented it to our Hadoop cluster. But yeah, Hadoop is not really real time, so we need to do the aggregation here at Hadoop and export it again into our online database or Oracle database, and we do it with Scoop. That's very fast. That's no big problem. Yeah, and we're very happy with it. Now again, what data do we really have? It's of course a timestamp. When did it happen? The date, time, what action was made, a page view. Another action maybe would be a bookmark event, or the premium products where you can analyze how many additional clicks you got, or with our ads you can buy on our page. Which content was seen. In this case it's the article with this ID. Where's the source? In this example the mobile site of France. And we have a NIMUS user identifier. It's a cookie GUID or it's a GUID. We save on every our visitors in a cookie, and it's totally anonymous, but we can see if the user comes back again. For our click tagging, the user identifier is irrelevant, but Jizzy will come back to that later. It's important for the recommendations. Yeah, but the data, these lines are stored in Hive for structure and easy aggregation, and it's partitioned by for the date and the hour. So if we want our aggregation, we can say, yeah, just do it for the last day or just do it for some hours. And we don't have to go over all the data, just select those data in these partitions. Yeah, what are we talking about? It's about 18 million data points. With data points, I mean such lines, as you've seen before, and 4 gigabytes of data per day. After our aggregation, it will be 12 values for each of our 2 million classifieds and 15 values for each of our 40,000 dealers. So at the end, after our aggregation, it will be 24.5 million values we will get back. And yeah, we do it nightly, every night at 1 o'clock. And about the performance, I will tell you later. We could do it more often, but it's sufficient to do it at night. Just to give you an example of how much code it is, that's a shell script. Yeah, it was our first product made with Hive and Hadoop, so it's still a shell script. If we would do it again now, we would do it in Hello. Yeah, at the top, that's the statement which creates the aggregation and saves it in a new created Hive table. We also have the statements to create a table in Oracle and export the data to Oracle in here. It's also done with Scoop. Scoop does the creation of the Oracle tables. Then the same again for the another step of customer aggregation and export the data, and just at the end say, okay, we're fine, we've done it, and other tasks in the database can happen. So I created a video for you. That's our Oracle database. Here we have those 2 tables we want to create. Yeah, you don't see it. It was just for yesterday, and now we want to create it for today. So I just execute the script. You've seen the slide before. Now Hive starts up. Oh, that's really bad. It's so small. I was hoping that you can see it better. Maybe I scroll into it. Yeah, the first aggregation takes maybe 2 minutes. I will skip that. I think most of you have seen HiveScope job executing. It's not very impressive. Just the result is impressive, I think. Yeah, a little bit more. Yeah, but as you can see, the aggregation runs, the script runs, and saves the data again in the Hive, in the Hadoop, in a structure how Hive can interpret it. But yeah, that's not really important because we export it with Scoop, and Scoop doesn't know about the Hive structure. if you execute scoop, you have to say, okay, the data in HDFS at this point is exactly the same structure as our target table in Oracle. And then it makes a fast push, and scoop works very fast. The only bottleneck is the Oracle database. So how fast your database is, so fast can be the export in our case. Okay, the map job is already done. Now the reduce job is done. Yeah, and then you see it. Here we create the table in Oracle, it's already done. We do the export, it's already done, and now we go on with the next aggregation. This was about 100 megabytes, which were transferred in, I would say, less than a second, and several thousand of lines. For this video, I just aggregated 2 hours, not the whole day, because the whole day would take about 15 minutes, 15 to 20, depends on our performance of the cluster, if other jobs are running, or if our Oracle is responsive. Yeah, there again, the other aggregation job is done. And that's it. Just hit refresh in another tab. And just for confirmation that the tables are really there, there is the 9 at the end yesterday, not only the 8. Yeah, I told you, it's only 2 hours for this example. Yeah, and that's it. That's my whole presentation. First question?
Have you thought about just replacing Oracle with Impala, for example?
Replacing Oracle with Impala.
Well, if it's so quick, you don't need to export
Yeah.
the license fees.
Yeah, really good question. I already thought about it, but I don't know what our DBAs say about it. Maybe we do it later on. But if you, as you already heard, Impala needs a really big amount of memory, so maybe it's not the right decision, not the right solution, but we will discuss it at a later
But
time.
the aggregated data is not that much. You can store it easily.
Yeah, but the question is how frequently this data will be read from the application, right?
Yes, but you don't want, our policy at the moment is that we don't want to use our cluster for online things. We just want to use it for batch processing, and because we want to not have any dependencies about the systems, because it's part of stability of the overall.
And one thing it did not tell you is that it's only aggregation for today, and we save this day in the Oracle database. But in the second slide, you can see that their customers can go back in time and see a whole range of 1 year in one view. Maybe that's also possible. I don't know.
I mean, the main reason is we have this high available Oracle cluster as our front applications depend on it. So yeah, with Impala it would be possible, for sure. And it wouldn't even cost so much memory as it is very small data. But yeah, we have this high available cluster, Oracle cluster, and so we transfer the data over there, which is only a few megs, and be happy. And yeah, this is quite, I mean, Impala is, yeah, Cloudera calls it 1.0, but other companies would call it pre-alpha.
Good luck instead the data you are storing and generating as an output of these batches. There is a table structure is there's 15 columns, what is told as a result of your job set? What you are giving customer and
Yeah, it's those 15 valid, 15
columns.
columns. Yeah. So we just do a key value access.
then you can analyze this data.
Yeah, some aggregations we do then in real time on the application.
Do any analysts inside Autoscout use any kind of reporting tools and access this data directly, or are these tables just for the dealers who access their statistics in their web portal page? Those data are also available for, basically all the data are available for nearly everyone which needs it in Autoscout. So if you want to, the product manager or developer, analyze the data, either they are in Hadoop with Hive or in any classical database, and you can access to it. We have a front end for accessing our Hive tables, which is for every developer or product manager which needs it. And you can just have to set up this SQL statement. If you know the structure, well, there are some. Okay. And are people using it? So do they know? Yeah. Okay.
And in my department, of course, data analysts do it also from time to time.
Okay.
And so we stick with our own front end to hide out some important columns. But it's just to, and this is one of the reasons we are on this Hive service too, as we access to Hadoop for business front end using Hive server.
Okay.
Any other questions? Then, shall we go? Wie kann ich das Escape drücken und dann. Ich habe nichts umgeswitcht.
Nee, schon.
Das schon.
Nee, das Ding hat so seine eigene Formulierung. Das war deine, ne?
Schock. Ja.
Ab hier.
Genau. Das nächste.
Einfach kurz nicht.
Genau. Okay. So let's talk about recommendation. Before that, my name is Jean-Charles Thomas. I am team lead for the Linux and data team at Autoscout. So we are administrating and our Hadoop cluster and our databases. And we are trying to convince our product manager that we can make a lot of beautiful products with our data. That's quite a hard thing. So what I want to show you is a recommendation engine that we built based on Mahout to show our product manager that there are many insights to get from our data. And the purpose was that what can we do with the same data as Sebastian talked about. What can we do with that? So recommendation, first of all, I think everybody knows about recommendation. Amazon or YouTube or any portal that everybody knows, it is possible to get some different kind of recommendation. People who bought that also bought that. You may like this, and you may you probably understand that every kind of recommendation has its own algorithm in the background. So I'm not a data scientist. I'm just a man that likes to work and to play with data. So I want to talk to you also about this recommendation because just to demystify a little bit the data scientist role, which is a buzzword at the moment, it's possible to make recommendation and to make some quite interesting data analysis without being a data analyst or data scientist. What do we have at Autoscout? Well, just about recommendation, what is a part of the collaborative filtering methodic. So it is based on the user experience and interaction on a website. So you have to look what people are doing. and try to understand the patterns and to make prediction for the user based on item. And well, on the past data, then you try to predict the future, so predict what the people would like to eat. Which kind of data do we have to run such kind of recommendation on the Autoscout platform? We have data which are mostly based on views on cars ads. So this is our so-called detail page. If you already surfed on our page, you see cars, and if you click on one car, then this will be logged on our log file. And okay, if we have the possibility to identify the user, then it's already information. This user show that car. We don't have any rating of articles. If it's good, not good, like it, or do not like it, there is no such kind of thing on our platform. And we don't also are involved in any transaction. So we don't know at the end exactly if this car was sold or not. It disappears because the dealer just don't have this car, don't want to sell this car anymore, maybe it's sold, but we don't know exactly about what happened with this car. So we only have the interaction of our user on the detail page. So what we can do is, customer who look this car also look at that car. That is a kind of recommendation that we can do. And the wording is very important here. What are the challenges to do that? Well, you know a little bit more about our data. We have about 2.3, 2.2 million cars in 12 countries. About 13, well, Sebastian, 18 million real human hits on car per day, and about more than 1 million unique users per day. The challenge also is that we have about 30% of changes on our car every day. So if you want to build some recommendation, then you have to rebuild the recommendation every day or as fast as possible. And well, I will show how we handle this. So how does it work? The recommendation, just a bit of wording. So you have users which interact with items. It's called preferences. And you have some kind of you have rating. You have some so-called explicit rating. So you user say, okay, I like this, I don't like this. Or well, you have implicit rating. It's just a Boolean. Well, I look at that car, or I didn't look at that car. So as I said, we don't have explicit rating, so we only have implicit rating. So basically, you build a user item matrix, and mathematically it is based on a leaderboard-based approach. And for the rating, you just use Boolean. So here you have, for example, 3 cars, which have been already looked by some people. Alice looked at all the 3 cars. Bob looked at the 2 cars on the right side, and Peter only the Fiat car. And Mark is looking at the Fiat car. What would be the car that we could recommend for him, based on the cars that were already shown by the users? Yes.
Short question. Did you also experiment with taking the visit time into account? So saying if you are on a minute on a car page, you might be more interested compared to being 2 seconds on the page, which likely means it's not interesting.
No, we didn't tell this because we don't have this record. We just know if the page was called or not, but we don't have the time it was spent on the page.
Okay, because I thought I saw the timestamp with your log events.
Yeah, we have the timestamp, but you don't know how long it was spent on each page. You just have to know what's the first call of the page, the call of the page.
You can calculate it.
So depends. If you are on a page, call the page, and you go to drink a coffee, you don't look the page.
Our users tend to open tabs. This is also this is like this. So if you look at this tracking, you see a user joining, see the list view request, and then see almost everything popping up very fast. So no, it's not so easy to calculate.
But it would be an interesting thing. You're right. That would be things to look at if there are some for some kind of rating. So the data, the basic data are those already described by Sebastian. We have the time, the type of view, mobile, for example, you have the article ID or a car ID, the application, and this cookie GUID. And this cookie GUID is for us the user ID. So this cookie ID is for when it is set the first time on the browser, it is available for 12 months. So we can really, based on the browser, identify the user. Those data are collected in Hadoop, as described before, in a Hive table which is partitioned by hour, and it's come with foo. Well, I don't need to go deeper in that thing. So how do we process the data to work with MAUT? Because we use MAUT for this, for the recommendation calculation, because you will see MAUT is for this kind of analysis quite simple, quite easy to use. You don't need to be a data scientist. That's the nice thing. So we have the GUID and the article ID. You have to transform this GUID in some kind of integer number, because MAUT can only work with number. Math with string is difficult. So the first part of the processing is to convert this GUID in a string. So that's the first one. And then the second part of the pre-processing is to build a table, a Hive table, which is making the mapping between the new user ID and the article ID. And with this, you have your preference table. Preference is this user ID 1 looked at this article, and so on, for the complete day. It's quite basic and simple. So you have to also to maybe clean up the data. You don't want to, for example, to have the user which looked a lot of cars. It seems very not very understandable that a user is looking 100 of cars. Even if it's a pixel, sometimes there are robots which are loading the pixel, and you can filter them with a supplementary pre-processing. Well, this kind of processing with the Hive is very, very basic. And then you have prepared the preference table. So the preference table, I'll go back, is this structure, user ID, article ID, and you put this in MAUT as input. MAUT is very easy. It is installed. It is very easy, by the way, to install on your Hadoop cluster. And it is a set of libraries that you can call either with Java, or you can call on the batch processing, on the command line. So for the item similarity method, there are a lot of parameters, but just to test to see if it works, you don't need a lot. You just need the input. So you need to give the input for the path of the Hive table. You have an output. You have a temporary directory for when the processing is running, and then you give, most important, the similarity class name. You have several algorithms, and well, the one we chose, because we found it was the best log likelihood. And Boolean data is true, it means that you have implicit rating. So it's very easy. MAUT run in the item similarity is running in 3 MapReduce phases. Well, for those about 10 or 15 million data, it takes about 5 minutes on our cluster. It is, by the way, much more performant with the 0.7 version. And then you get as output a text file which is containing those data. So you have article ID, one article ID, another article ID, and a scoring. So the first article ID and the second one are the combination which were found. So this article ID, the first one was looked with the second one together from some people. And you have for the same article ID, the first column, then you have all those articles which were looked together with the scoring. So the scoring is more or less the combination which were the most looked together and have the best score. And then in blue you have another article. So this is more or less it is just the result of the output, and basically you just have to export this in a database, for example, and use it for your application to show some recommendations. So you can say, okay, if an article ID is shown, then I can present all the other articles, and I can sort by the scoring. You can also test the validity of your recommendation. If you have some test data, then you can run those test data against the result here with Mount and see the quality of the recommendation you have. Well, one of the challenges I told you is that we have every day we have to recalculate, or not to recalculate, so to recalculate the new recommendation. And one of the challenges is, for example, the scoring, because the scoring is between 0 and 1, and if new recommendations are coming, and how can I, or the same recommendation with another scoring, then it's a challenge. So just go back here, Hadoop, the tracking data, we create a preference table with Hive, we run the calculation with Mount, and then we have this item similarity table that we export to our online database. So, how to integrate new data? That's the point. Day one, I have one article ID with similarities with the scoring. And day two, I have the same similarity with another scoring. For example, the second one, day two. So how can I integrate both of them? And it's a problem with Mount. If you have very static data, then you can run a complete recommendation for all your data, and then 6 months later, or anyway, so you recalculate it. But if you want to put the data together one day after the other, you have this problem of the scoring, which is difficult to aggregate from one day to another. So what we have done is that, okay, this scoring is not suitable for us, so we have to post-process the data to get another scoring. So what we have done is we have chosen to make it very naive. So we just look back at the similarities that we have, so the combination, article ID 1 and 2, and we look back in the preference table how many times this similarity occurs. For example, 5 times here, day 1, and the second one 3 times. And day 2, okay, we have the same similarity here, it comes once, and another one once, and the new one, the green one, 10th. And at the end, if we want to combine both days, then we just increment the similarity factor, this hit factor for the similarity. So it's very naive, but it works, because at least you can aggregate the data one day after the other. And you can do this with pre-processing very easily with Hive. So it runs with Hive here, and then we export those data in our Oracle database.
Sorry, did I get it correctly? So you use Mahout to create the pairs of article IDs?
That's right.
And then you calculate the similarity based on your data in the Hive tables?
That's right.
Just count.
Sorry?
Just counting it in there.
Just counting. That's right.
But why do you need Hadoop? So getting these combination of
Mahout
article IDs, these article IDs is a simple SQL query. So
Yeah, it's correct. Well, at the beginning we changed our processing. At the beginning we had only the scoring. We had the scoring, and then we realized with the scoring it's not suitable for aggregation. So you need a way to calculate the similarities anyway, either with SQL or with Mount or anything. So we just keep the process to calculate the combination, the similarities, and then we post-process afterwards.
So basically the score coming from Mahout, you ignore it.
But Mahout is also faster. We tried it with normal Hive to analyze the data, but Mahout is faster.
That's faster.
It's faster. So it's not
Well,
bad
this-
idea to stick with it.
in fact, we could complete redesign our job in this case, and to make it only afterwards with SQL or with Hive. It would be possible. But if we want, the next step would be, for example, to find some ratings for our car, then you will need Mount anyway. So. Okay, so the complete summary of the processing: tracking data, pre-processing for the preferences. Then we run Mount for the similarities. Then we post-process for the scoring. It goes in our similarity daily table, and then we export all the data in our Oracle database for the front end application. So, Hive in combination with Mount, just very powerful because you have very much flexibility, and Mount for similarity, at least, depends upon your use case, is quite easy to use and not very complicated to understand. You don't need to be a data scientist, and there is a very good book to go deeper in this. So, just just try it yourself because it's a nice tool. Yes?
For the scoring, did you use a library in mind? Or did you code it yourself?
The scoring that we use, ourselves, yeah, we just do it with SQL,
Okay.
with Hive.
And
Yes?
you said that you are just having this Boolean information, looked at the page or not looked at the page. Did you at any point in time experiment with any kind of rating or feedback, or was it never on the Autoscout platform?
You mean about the recommendation itself?
Yes, that you could, for example, any kind of ratings into account. So the question is whether you had at some point and put the rating away.
We have some few ways for rating. For example, there are some people which are parking some cars on their account, or there are some mails, some contact emails which are sent to dealers about cars. So we could use this information. We didn't use it at the moment because those contacts those are very, very scarce as compared to the amount of data that we have. So statistically, most probably it will not play a big role. But I think your suggestion to look at the time would be also something that we could look at. Yes?
Hit numbers, how often people click on your recommendations?
So we tested this for a few months ago, on our page, on our detail page. So on the detail page that I showed at the beginning, so we show the recommendation, and we had a conversion rate at about 30%. So about 30% unique users are looking at the recommendation, which is one of the most successful product on our pages. So we are not live yet. It should go in the few weeks. Yes?
You said you have about 30% of changes every day.
Yeah.
But you're still using the information on which people looked at the same products. Why are you not using the product information itself? Like some kind of clustering on the cars themselves, because that should give you much better information with such a high rate of change.
Well, changes are changes or new cars. So, for example,
so if you have a new car, then probably very few people have looked at it in that first day. So you wouldn't be recommending it to users a lot, just because you don't have that much information.
Yeah.
But actually, that might be one of the most interesting cars for the returning users to look at, because that's new and they haven't seen that if they haven't been to the page 2 days, 3 days ago. If you use the information about the cars, like kilometers and price and color and all, what kind of car it is, you do some clustering of the cars and use that for recommendation. Then you don't need this click information, and you could recommend a new car immediately.
Yeah, it depends which kind of recommendation you want to do. If you want to make a recommendation based on the people which chose this car also chose this car, which is a very easy use case, then you don't have any other. Yeah, it's very. I mean, it's very straight away. If you want to make, or maybe I didn't understand your question, but you could make some recommendation, maybe with the car you like. Is that what you mean, or?
Basically a recommendation of similar cars that have the same.
Yeah, but what is a similar car? Is it a car which is based on the color, the same engine, or is it based on the car that the user looked? He also looked this car, so it is also, I mean, similar. It's not a very detailed. You can make a lot of things with similar. It depends how do you define similar.
Right. You need to define a distance measure between cars.
And we have also on our platform. You have the possibility to choose for cars which are van, for example. And so you choose for van cars that are similar, all similar together, but different makes and models.
Right.
So this is also some kind of recommendation. Here we want to have a product which is based on the user interaction on our website, and not on what we think could be interesting from the user. If you are a user and you are looking those cars, then interesting for the other users to see that other users also look at car. It's not our Autoscout decision, but it's the decision of the customers.
Your suggestion with clustering the cars can be done by the user using the search interface, more or less. So he can select what he is interested in and then gets a list. So we have this not directly as a recommendation, but as a search interface. So we really are more interested in what did real users do, not what the cluster says user should do. And this is one of the points we stick with this one and do not cluster all accounts.
Does it make sense? Or?
Yeah.
It's a product point of view. Yes?
In terms of data usage, are car manufacturers interested in this kind of evaluation data, or do you work with them together, or?
Yeah, the car manufacturer, when they saw this product, they said, okay, but can you please change the rating, or the scoring, so that I'm on the top of the car for the dealers which are paying. So, yes, they are very interesting, of course. But then you are changing the engine in the background if you do that. So it's always a trade-off with our product manager. Our product manager wants to be pleasant with the dealers, and we say we want to show the reality of the data and not.
Okay, but what I meant was more not the dealers, but the car manufacturers.
Yeah.
Is this kind of data like which kind of people do like which cars, even in a?
I don't know exactly. So I don't. In that case.
Yeah, but I don't think they know anything about the user, because you cannot map your anonymized ID to a user profile, right?
Yeah, no, we don't know
so there is nothing
so much about the users.
Yeah, we know.
And most of our users are even not logged in. You get as a customer, as someone searching for a car, you gain not so much benefit from logging in.
Okay. How many users do log in?
Very few %.
Okay.
So okay, no other question? Thank you very much.
Yeah, I would put that's a question to the audience. I mean, we run a bit over time as we had so many questions. So we have another talk. Would you like to prefer have a break or just go straight forward to the next talk?
Take a 10-minute break, but then on time back.
Well, it depends on the people.
Yeah. Someone needs a break?
Yeah, we are for a break. Yeah.